You build a container, it runs. Something goes wrong, you want to see what happened, what it logged, what it printed, what things broke. You type Docker logs and get nothing. It's empty. Your application was logging the whole time, writing to a file inside a container. But Docker never saw a single line. Today I show you why that happened and one rule that fixes it forever. Welcome back to the kingdom, DAC. This is image number 9 in Docker, 100 images, 0 to architect. I am Himanshu Gupta. Last time we learned ARG build time, ARG argument, build time variable, and the ARG to env handoff, and how to parameterize everything from banner text to base image. Today we tackle logging, not a logging framework, not a fancy tool, the philosophy. The one principle that separates beginner who lose their logs from professional who never do. Let us get into it. Here is the plan. First, we build a logger the wrong way, writing to a file inside the container, and watch our logs vanish into thin air. Then we will build it the right way, stdout and stderr, and unlock every single local logs feature. We cover follow mode, tail, timestamps, filtering by time. We talk about the 12 factor app and why factor 11 says logs are event streams. By the end, you will never write a log file inside a container again. Let us go. So, as we do in every video of our 100 images, we go inside the folder where our we are going to create a folder for our image number 9. So let's list, and pwd, we are already in images folder. Let's create a folder for image number 9, mkdir -p, if nested folder we are creating. Let's put a name 009 tiny logger, and so today we are building tiny logger, a small shell script that generates log entries with timestamps and severity level. Nothing fancy on the surface, but the lesson underneath is the one of the most important in the entire course, where your application sends its logs determines whether Docker can see them or not. And if the Docker cannot see them, neither can you. So let's start with the wrong way. Every beginner does this, and honestly, it makes sense if you come from a traditional server background. On a VM, your app writes to wall log app.log, you SSH in, and you tail the file. You read your logs, it works. So when people move to Docker, they do the same thing. The app writes to the file inside the container, and it works until the container stops. Then the container is gone, the file system is gone, the logs are gone, everything is vanished. So, but there is a deeper problem than just losing files. Even while the container is running, Docker logs shows nothing. Docker has no idea your application is logging. It cannot see the file. Docker only captures what goes to the stdout and stderr, that is standard error, and a standard output stream of the main process, that is PID1 inside the container. Anything written to a file is invisible to Docker. So let us build the wrong way first. For that, let's create a script vi logger wrong .sh. Inside that, so the script, this script, what it will do, it is using the sh shell script to run it, the first line. And then we have some statement which will print like logger is starting the wrong way. Then we have an infinite loop, that is while that is true, do this or do that. And then we are printing the date. This is the date format. So the date, year, month, day, hour, it will show this. And if whatever errors are it will show this and save it in wall log app.log, and it will write every 2 seconds. That is, and it will continuously doing it one after another. Okay, so uh, let's save the script first. Okay, and then as always, chmod plus x, make it executable. Logger wrong.sh ls-la. Oh, sorry. We have to move this inside our tiny folder. So logger into 009. Okay. cd2 009 folder. Okay. Here you will see it has a executable permission also. So move command is to move the files permanently, not copy it. Okay. Mm. Now, so this is scripts write every log line to wall log app.log using append director, that is double colon. Sorry. Uh, so this forward sign, it will append one line after another every time it writes it, every 2 seconds. Okay. So now create a Docker file. Let me clear the screen. We are creating the Docker file in the same folder as always. So vi Docker file. Remember, we use capital D while writing a Docker file. Then insert mode, and uh, be- before building it, let me just tell you about the Docker file. We are using the Alpine 3.2 base image. Then we have a work directory. So this is the default directory inside Docker. Then we are copying logger wrong.sh to our /f directory. Then we have run chmod plus x command so that it will take, and then cmd run that script. Okay. So now let's build our image. For that, we use docker build command, build hyphen t, and name of the image, tiny, uh, logger, uh, and tag will be wrong, and build context, take a docker file from this folder only. Okay. So let's try to run in our background first. Then we will see what is happening. Docker run, and the name of the folder we are giving here, and we are running it in detach mode. Detach mode means like it is running, going to run in the background. Okay, name we are giving to our container is logger wrong. So let's run it. Okay, so if you do docker ps, you will see one container is running. So, and cool. Now let's wait for a few seconds because logs are running every 2 seconds, and we just run a script which will just print the logs and append it to a file one by one line after another. Okay, so let's uh, let's run a command docker log and logger. This is the name of our container, docker log of the container. Okay. Oh, docker is not running, so let me start orb. We are using orb stick. Okay. Now again, wait. Oh, docker logs is there. My bad. Not the docker log. Okay. So you see it just print logger starting wrong way. Okay, only one line when we run the logs command. The container has been running for the like more than 10 seconds, but writing a single entry. It should write like every 6 second, every 2 second, but we just see a single line. And Docker log sees exactly zero of those entries right now. Okay, so it did not print any date. It just says echo, and it does not run anything inside it. If you see our mm, logo dot wrong, so first line it just print, but it never run this var log app dot log. Every 2 second it will print the date. Okay, so um, so but let us see logs are exist inside the container. For that, let's see let's go inside the container. For that, docker exec command and the name of the container. Then we cat our file var log uh, app.log. That is the path we given where. So if you see every 2 second, 11:53, 28, 11:53, 30, 11:53, 32. So every 2 second it is printing a date and time with system check passed. Okay. So three or four entries sitting in the file, like we have like more than 10, 15, 20 entries right now. So logging is working, but it is invisible to the Docker right now. So we run docker logs command, it is not showing. And the moment we stop this container, these logs are gone unless we explicitly save them. So let's remove the container docker docker rm hyphen f to remove container permanently. Logger wrong. Okay. And so container is gone, logs are gone. This is the anti pattern. Never do this, but for demo purpose, I just do that. So let's docker ps. You will see nothing is there. Docker ps hyphen a. No running container is there. Okay. So everything is gone. Now, there is a famous methodology called the 12 factor app. It is a set of 12 principles for building modern scalable application. Factor number 11 says this: treat logs as event streams. Do not write them to files. Do not manage log rotation inside your app. Just send every log entry to stdout or like standard output as an unbuffered stream of events, and let the execution environment handles the rest. In Docker, the execution environment is the Docker daemon. So when your process writes to standard output, Docker captures it. When your process writes to standard error, Docker captures that too. The daemon stores these streams, index them by the time, and makes them available through Docker logs. From there, you can forward them to any logging system you want, like Elasticsearch, Splunk, CloudWatch, whatever you want to use. But the application does not need to know about any of that. It just writes to std like a standard output and a standard error. That is the contract. This is not just a Docker thing. Kubernetes follows the same principle. Every container platform does. If your app logs to std out, it works everywhere. If it logs to a file, you need custom solution everywhere. The 12 factor rule is the foundation. Let us build it right away. So let's remove our logger wrong.sh. Let me keep it that for you so that I can push it to GitHub later. So let's create a new uh, script via logger.sh. Okay, then let me print. Okay, so this is the content of our. You will get the content or this file from GitHub if you want to. So before saving it, let me walk you through walk through this in a simple way. So if you see the first line, that is binsh, that tells the system run this file using the sh shell. Now the three logging functions we have, that is log info, log one, and log error. So first one, that is log info, it will this function is using echo info and $1. So it's a like reusable helper. When you call log info function, what it does is mm, it prints the current. So here the date. So it will print the current date and time with the tag info, and also whatever message we are passing, like whatever message we have passed. So that is $1 will take care of it. Then we have log one. Log one, same idea, but uh, like same idea, but tag here changes. Like tag is warning, and whatever we are printing the message, so it sends to this is uh, ampersand 2. What this will do, it will send the message to a standard error. Okay, so that will go to a standard error instead of normal output. Same with the log error. It will print a timestamp date, and with the error message, sorry, with tag error, and whatever we will pass it, it will go to a steady error again. Okay. Now, if you see these two lines, log info, like tiny logger is starting up, or DevOps AI Kingdom logger version 1.0, these are like two log info lines just announce that the logger has started and prints its name version. They run once only. Then the main, then we have a counter equal to 0, and the main loop is started. So uh, initially the counter is 0. Then we have a while loop with do. So it will loop forever. Then we have counter equals to counter plus 1. So and log info will show heartbeat, and heartbeat 1 system nominal. Okay, then we have a condition that if counter is divided by 5 equal to, like reminder is 0, that means like every fifth loop, like fifth, 5, 10, 15, 20. So it will using log 1, memory uses above 70. Okay, so with warning it will come. Okay, and if the counter is reminder is divided by 12, then that means like numbers divided by 12, reminder is 0, then log error will be like connection timeout to upstream. So this is a like two condition we have in if and else, and we are putting sleep for 3 seconds so that it will not bombard the screen like with all the logs. Let's save it first. Okay, no, so the as we see, the main loop sends a heartbeat every 3 seconds, and every fifth heartbeat trigger say warning, and every 12th triggers an error. This gives us a nice mix of log levels to work with. So let's create a Docker file or update our existing Docker file for this one to test it. Okay, so let me update in uh, here Docker file. Okay, so let me change the content. Okay, so same thing. We just change logger.sh with logger wrong.sh with logger.sh. It is doing the same, like we have the same script right now. Let's save it. Okay, now let's build a image out of it. So docker build hyphen t, name will be tiny logger 1.0. Earlier we have put the wrong as a tag, now 1.0, and build context is current. Okay. So now let's run docker run in a detach mode. So docker run hyphen d, name will be tiny logger, and the image we use is tiny logger 1.0. Okay, so docker ps, you will see our image is running right now. Give it some times to generate like some entries. Now see docker logs tiny logger. Let's see docker logs tiny logger. Enter. So look at that. Every single log line is there now. This time with timestamps, like timestamps, levels, Docker capture everything because the script writes to stdout and stderr, not to a file this time. So this is the difference. One change in where you send the output, and Docker sees everything. So in wrong, let me show you cat uh, script wrong. Oh, wait, logger wrong.sh, logger wrong.sh. So here we are putting everything to a file. Okay, so Docker did not care about it. Like it is not able to see it. But if we are putting like stdr or stdout, then Docker daemon will capture everything. So this is the big difference. One change in where you send the output and Docker sees everything. Now let me show you the flags that makes Docker logs truly powerful. Okay. So again, Docker log logs and container name will be tiny logger. So you will see every 3 seconds uh, it is printing logs. Okay. Uh, Now run it again in a detach mode. No, before running it, let me show you logs with hyphen f tag, uh, and enter it. Now watch the lines appear live every 3 seconds. It's just not like showing what is already there, but it is showing the live logs. So docker logs hyphen f, uh, every 3 seconds a new heartbeat you will see, every fifth one a warning, and you are watching your container breathe. So for coming out of it, press control c, so you will come out of the loop. Now if we want to tail our logs, so for example we just need to see last few lines, so just use linux tail command with docker logs tail hyphen hyphen tail hyphen tail. Let's say we just need like 10 lines, last 10 lines. So tiny logger container name. Okay. So you will see the last 10 lines of the of the most recent entries in production. When a container has been running for hours and has thousands of log lines, hyphen tail is a how you skip to the end, see what is happening right now. Timestamps. Now see docker logs hyphen t, then tiny logger. Okay. So now every line has a Docker generated timestamp at the beginning. In addition to the timestamps, are script prints. The Docker timestamps is in RFC 3339 format with nanosecond precision. Okay, this is useful when you need to correlate logs from the multiple container that might have different internal time formats. Since show logs for let's go to another flag which will show logs for a specific time window. So for that, let me clear this. So docker logs hyphen hyphen since 30 second and tiny logger. Okay, so in last so what the only the entry from the last 30 seconds will be shown. In an incident when someone says it broke 2 minutes ago, you can zoom in immediately with since 2 minutes. No scrolling, no searching, no grabbing through giant files. Docker already indexes everything by time. So so we can also combine the flags. For example, docker logs hyphen hyphen sinc since 30 seconds and only hyphen t, like add the docker timestamp with tiny logger, and then you will see docker timestamp also here. So last 30 seconds with docker timestamps. This lets compose naturally. This is a good tool design. Okay, now a very important thing: standard error versus standard output. Uh, I want to highlight something important. Our script sends info to standard output and uh, warning, and error to standard error. Docker capture both. Docker log show both mixed together in chronological order, but they are separate streams internally. In production, this separation matters because log drives and aggregation tools can route them differently. Errors can go to a paging system, info message can go to a long-term storage, and the application does not need to know about any of this routing. It just send the right level to the right stream, and the platform handles the rest. This is power of the 12-factor approach. Your application is simple. It prints to standard output and a standard error. The complexity to the long routing, storage, rotation, aggregation, all of this lives outside the container in the platform. Your app stays clean, the platform stays flexible, everyone wins. Now, let's inspect with the lazy docker again. As always, lazy docker. Okay, navigate to the containers here. We have one container, uh, tiny logger. You can see the logs streaming right there in the lazy docker continuously. You don't have to search anywhere. You can just come here, see the logs. Okay, the same output docker log shows, but in a nice terminal UI. You can see the container status, resource uses, the log stream all in one view. This is why LazyDocker is a great companion tool. Navigate to images and find tiny logger 0.1. Okay, look at the layer. Alpine base first, uh, then work directory layer is there. Okay, and after that, like copy, then run, then cmd, where we are running our script. A queue for quitting from the lazy docker. Now we can see the same thing, like how the layering works with docker history command. History tiny logger, oh, yeah, logger 0.1, our image. No, wait. Docker images tiny logger. Okay. Docker inspect. Oh, not inspect. Docker history. Okay. Read it bottom to top, the Alpine base layer, then work directory again. Same thing, the copy layer, the run chmod, then finally cmd. Notice how small this image is. We did not install any logging framework. We did not add any logging library, just a shell script that echoes to stdout and stderr. Okay, that is all you need. The best logging setup is the simplest one. So now let's save the work. So let's remove the container first. For that, docker rm hyphen f tiny logger. Now get add all get uh, commit for with message. Okay, that is our image number 9. Tiny logger, docker logs, and std out philosophy. Okay, and sorry, get push to pushing to our GitHub repo. It's done. Okay, so now interview question or interview moment, you can say. So interviewer asks, how does a container application handle logging? Here's the senior answer, senior level or architect level answer. A containerized application should follow factor 11 of the 12 factor app methodology, like treat logs as event streams. The application should write all the logs output to std out, like standard output and standard error, never to files inside the container. Standard information and debug message, like standard information in the debug messages goes to the standard output. Warning and errors go to the standard error. The application should not concern itself with log routing, storage, or rotation. The reason is that Docker captures standard output and a standard error from the container's main process, that is the PID one, and makes them available through the Docker logs command, and through configurable log drivers. These drivers can forward logs to centralized systems like Elasticsearch, Splunk, Fluentd, or cloud native services like CloudWatch or Stack driver. If the application writes to a log file, uh, writes to a file instead, Docker cannot capture those logs. The Docker logs command returns nothing, and you will lose all the benefits of the platform logging infrastructure. In a Kubernetes environment, the principle is even more critical because the kubelet reads container logs from std out and standard error, and log aggregation tools like Fluentd or Promtail are configured to collect them from the standard location. File-based logging breaks the entire observability pipelines. That answers cover the methodology, the mechanism, the production tooling, and the Kubernetes angle. It shows you understand not just Docker, but the ecosystem around it. Now, let's recap on our finger what we learned in this uh, video. So first we use like Docker capture the standard output and a standard error from PID1. That is the only output Docker can see. Uh, if you write to a file, Docker sees nothing. The second, Docker logs is your window into container output. Use -f to follow or hyphen tail to skip to the end, -t to timestamps, hyphen sense to filter by time. Third, 12 factor app. Factor 11 treats logs as events, event streams. Write to standard output and standard error. Let the platform handles routing and storage. Fourth, use standard error for warnings and errors. A standard output or for information messages. The streams are captured separately and can be routed differently by log drivers. Uh, Fifth is never write log files inside a container. The files dies with the container. Docker cannot see them, and you lose all the platform level log management. Now the homework. Take our tiny logger and add a fourth log level like debug. Have it print debug message every heartbeat, but only when an environment variable called log level is set to debug. Use an if statement to check the variable. build the image, run it without the variable to confirm debug messages are hidden, then run it with -e log level debug to see them appear. Post your solution in the comments. Next time, image number 10, the checkpoint. Level 1 complete is here at the point, like image number 10, and we push an image to Docker Hub for the first time. Tags, digest, registries, your image goes public. That is next. If this helped, subscribe and join the kingdom. 100 images, one concept at a time, 9 down, and we are one away from completing the level 1. And remember, don't be the same. Be the better. Be better always. Thank you.